Hello there, I'm Sebastian, an integrations engineer at Operant AI, and in this video I'll show how AI automation workflows can unintentionally expose sensitive data, and how we can secure them directly inside the n8n platform, using a custom Operant node we are releasing. Let's dive right into it. AI workflows are becoming a core part of automation, but they introduce new security challenges. They are dynamic, non-deterministic, and often interact with external tools and services thanks to the MCP protocol. In this demo, I'll start with an insecure workflow that looks fine on the surface, and then we'll secure it step by step using Operant directly inside n8n. Let's begin with an insecure baseline and this default setup. We have a simple AI workflow, a chat style user input, an AI agent, and an MCP tool that fetches external data from an URL. At first glance, everything looks fine. The model may even refuse to output sensitive information, but that doesn't mean the system is secure. Now let's examine the first vulnerable point, the user input. In this example, the user provides sensitive information, a social security number as we can see, but it could be any type of PII, PHI, or financial data, like credit card numbers and passwords. And even if the model has guardrails, that data is already left the user. It's been forwarded downstream, included in prompts, and sent to the AI provider and external systems. So even if the output looks safe, the sensitive data is already out. Now, the second vulnerable point is AI tools. Using MCP, the agent can dynamically call external tools. That's powerful, but it also expands the attack surface. In this workflow, the MCP tool fetches data that includes sensitive information. And even if the model doesn't repeat it, the data has already been retrieved and injected into the agent's context. This highlights a key problem with AI security. Most guardrails focus on what the model says. They don't protect what the system handles. In non-deterministic workflows with tools, sensitive data can move through the system without ever appearing in the output. Let's take a look at Operant and how it can help us. Let's examine this other secure workflow example with Operant securing it. Operant provides runtime security for AI systems by inspecting and controlling data flows, not just model outputs. We've integrated Operant directly into n8n through a custom node. This makes security part of the workflow itself. Let's take a closer look at the Operant n8n custom node. The goal of this integration is to secure AI workflows directly at the automation layer. The node inspects user input before it reaches the language model and enforces Operant policies at runtime. To set it up, you only need the Operant credentials, your API keys, and authentication token. You also provide some basic context, like the AI provider and the model being used. Once that's configured, you simply drop the node into your workflow, and you're ready to go. Operant also secures MCP-based tools through the MCP gateway, which we are going to see in the demo as well. And for deeper instrumentation, Operant provides an SDK that lets you secure AI provider clients with a single line of code. Let's go back to the first example and secure the user input with Operant. In this case, we are still getting sensitive data from the user, but we're redacting it before it reaches the LLM. Operant analyzes incoming messages in real time and detects sensitive data like PII and financial information. Based on centrally defined policies, the data can be redacted or blocked entirely. And if we take a look at the OpenAI logs, the sensitive data never reaches the AI model. Now let's focus on securing AI tools. Operant's MCP gateway sits between the agent and the MCP servers. It inspects the tool responses at runtime and applies security policies before the data reaches the model. This is critical because tools are often implicitly trusted. Operant also acts as a governance layer for MCP. From a central place, you can control which MCP servers are allowed, which tools agents can access, and under what conditions. Instead of trusting every tool by default, you enforce least privileged access across your AI ecosystem. And why edge security matters? Well, in many cases, you don't control the AI application itself. You may not control the model, the provider, or the AI agent. That's why securing the edges of the workflow, user input, and tool interaction, is so important. To summarize, AI workflows are vulnerable by default. Sensitive data can leak even when outputs look safe. MCP introduces new power and new risks. For this, Operant provides centralized policy enforcement for the sensitive data and MCP governance. And with our n8n integration, AI security fits naturally into existing automation workflows. This is how teams move from experimental AI to production-ready systems securely.